We will first start with the basic definition of differential equations. So let's see what is first differential equation and how it can be expressed. So let me write the first point. Okay, so we can write differential equation in the form of I'll give two examples. Example one is dy by dx plus y square equal to sine of x. So we can say this is a form of differential equation. And second example is we can write dy minus x dot dx equal to y square dot dy. So the expression of this form or the equation of this form, we can say it's a differential equation. And now let's see what are the types of differential equations. Let me see other example. We can also write example 3 as dou u by dou x plus dou u square u by dou x dot dou y equal to 0. So this is our third form of differential equation. Now let's see different types of differential equation. So what are the types of differential equation? So first form we can write, we can say it's ordinary differential equation, or we can say in short form it's ODE. Now we can represent ODEs by some examples. So I'll say example 1 as x dot dy minus y dot dx equal to 0. And second example is x square d square y dx square minus y dot dy by dx equal to sine square of x. Now the other type of differential equation, we can say it's partial differential equation. So let me write it. Partial differential equation, or we can say it is PDEs. So let me give you some example. For example 1, we can say here. Okay. So examples 1, we can write dou square u by dou x square plus dou square u by dou y square equal to 0. And second example, we can say dou square u by dou x square plus dou square u by dou y square equal to function of x and y. So we can say it's a source term basically, and here it's known source term. Now let's see third example. So we can write in this form also, dou u by dou t equal to dou square u by dou x square. And let's see final example, example 4, dou square u by dou t square is equal to dou square u by dou x square. Now let's see other basic definition of the differential equation. So we can write, so let's study about the order of differential equation. Order of differential equation. So what is the order of differential equation? So we can say order is the highest order or derivative occurring in the given differential equation. So it's the highest derivative occurring in the given differential equation. So let's say example. So if we want to find out what is the order in a given equation, so let's see an example equation. Suppose our equation looks like this: dy by dx plus x dot d square y dx square plus 4 d cube y by dx cube plus d4y upon dx4 is equal to some source term 4xy. So what is the order of the differential equation? So first we have to find out what is the highest derivative. So here we see the highest derivative is 4. So we can say the order of this differential equation is 4. So the order is 4. Now let's see other example. Example 1, let's say. Now let's say example 2. So example 2 we can take as dou u by dou x plus dou square u by dou x dot dou y plus dou cube u by dou x square dot dou y plus dou cube u by dou y cube equal to 0. So what is the order of this equation? So we have two terms here. First one, this one, cube, and this one. So the order of our differential equation is 3. So order of this equation is 3. Now let's study about the other definition, which we can say it's called the degree of differential equation. So we can say the degree of differential equation is the highest integral power of the highest order occurring in the given differential equation. Let me write it. It's the highest integral power of the highest order derivative, or we can say derivatives occurring in the given differential equation when, so it's very important here, when it is free from fractions and radicals. This is the main point. It should be free from fractions and radicals. Let's see with the help of examples, some examples. Let's say example 1. dy by dx power 5 plus x dot d square y by dx square power cube plus 4 dot d cube y upon dx cube power 8 plus d4 y dx4 power 10 equal to 4xy. So what is the degree of the differential equation here? So first we have to find out what is the highest order of the derivative. So the highest order derivative is, first here we see it's 4. So order we can say is 4 here, order equal to 4. Now we have to find what is the power of this order. So the power of this order is here 10. So we can say the degree of this equation is 10. So first we have to find the order. Then what is the power of the order? So highest like order of the power is 10. So we can say the degree is 10 here. So let's see with other example. Example 2. So dou u by dou x cube plus dou s square u by dou x dot dou y power 9 plus dou cube u by dou x square dot dou y power 8 plus dou cube u plus dou y cube equal to 0. Its power is 10 here. So first we have to find out what is the highest order of the derivatives. So first we have to find out the order. So here we see we have highest order here and here. So order is 3 basically. Now which order have the out of this order, out of these two orders, which have the highest power? So the highest power is here 10. So we can say the order for the equation is 10. Now let's see with other example. So let's example 3. So suppose our equation look like this: y plus e power dy by dx is equal to sine d square y dx square. So here we see that our sine term is not free from our like basic variables. So it consists of y and x term. So in this case we can find the order. So order is basically 2. But in this case, sorry, it's degree equal to 10. Yep. So order in this is 2, but since this sine term is consisting of the y and x terms, so we cannot find the degree. So in this case we cannot calculate the degree. So for this equation, degree doesn't exist. Now let's study about the other definition. Let's say we can call it as linear differential equation. So equation is said to be linear differential if they meet some criteria. So let's study about some criteria for telling that equation is linear. So the first criteria is the power or degree of the dependent variable must be 1. The second criteria is the power or degree of the derivatives of the dependent variable must be 1. The third criteria is the transcendental function, we will see later, should not be a function of dependent variable. Now the fourth and last criteria is the product of dependent variable and its derivatives should not occur. So these are the main 4 criteria for telling that equation is a linear equation. Now, what is non-linear differential equation? Okay, so this was the 5th point. Moving to the 6th point. Non-linear differential equation. So a differential equation which is not a linear, so it's a simple definition. So equation which is not linear is called non-linear. So any of the 4 criteria which is not met, we can say that equation is non-linear. Now let's see some examples and okay. So first example, x dot d square y upon dx square plus y dot e power x square plus cos cube y plus dy by dx plus d cube y upon dx cube equal to 0. So in this case, the dependent variable is y. So we can say dependent variable is y. And if we see the highest power, this is the highest order, and the degree of this equation is 1. So every criteria like above 4 criteria is met. So we can say this equation is linear differential equation. Now let's see other examples. Now suppose our equation looks like this. No, not this one. Okay. Dou u by dou y plus ux square y plus sine of y plus dou square u by dou x square plus u power 4 equal to 0. So in this case, what is the dependent variable first? So in this case, the dependent variable is u. U is the dependent variable. And the maximum power is 4. here power is 4. And what is the power of this equation? For this equation, power is 1. For this equation, the power of u is 1, not u. And in this equation, the power of u is 1. But in this equation, the power is 4. So it's non-inconsistent. So we can say this equation is nonlinear because the power of the dependent variable in each expression should be the same. So we can say should be the same, that is 1. So we can say this is nonlinear differential equation because the power here is 4, not 1. Now let's see other example. Dou by dou x plus dou cube y upon dou x cube plus y plus e power 4 plus dou square y dx square power cube equal to 0. So first identify what is the dependent variable. So in this case, the dependent variable is y. And let's identify the power. So its power is 1. Power is 1. Power is 1. Doesn't matter. But in this case, the power is 3. So not 1. So we can say it's nonlinear differential equation. Now let's move to other examples. We can take the example of partial differential equation. Dou u by dou y plus dou s square u by dou x square plus sine u equal to 0. So first identify the dependent variable. So the dependent variable in this case is u. So here u. Now let's find the power. So power is 1 here. In this case also power is 1. But this is transcendental function because u is the function of some trigonometric function. So function of this form we can say transcendental function. So the expression which contains the transcendental function is nonlinear differential equation. So this is nonlinear differential equation. Let's move to other example. Example E. X square dot dy by dx plus y dot d square y upon dx square equal to 0. So what is the dependent variable in this case? Y is the dependent variable. Dependent variable is y. Now let's find the power. Sorry. Power is 1 here. Power is 1 here. But see here. According to the fourth rule here, the product of the dependent variable and its derivative should not occur. But in this case, the product is occurring. So it's dependent variable and its derivatives. So this shouldn't occur. So if it's occurring, then this makes our equation nonlinear differential equation. So this equation is also nonlinear differential equation. Now let's start with the other topic. In the next topic, we'll study about what is the homogeneous and non-homogeneous differential equations, and we'll see some more examples. And for now, thank you.